Good morning everyone. I am Dr. Satish Kr, Assistant Professor in the Department of Electrical and Electronics Engineering, ATME College of Engineering. I am handling a course called Ability Enhancement Course Scilab or MATLAB for Electrical and Electronics Measurement. The course code is BEEL456B. Today I am explaining a first experiment which focuses on the design and analysis of resistance measurement using Wheatstone and Kelvin's double bridge. Learning objectives: to measure the low resistance using the Wheatstone bridge. Second objective is to measure the low resistance using Kelvin's double bridge. First we will discuss about Wheatstone bridge. Okay. The Wheatstone bridge is a circuit used to measure an unknown electrical resistance by balancing it against known resistance. It consisting of 4 resistors arranged in a diamond shape with galvanometer connected between two junctions. The bridge is balanced when the ratio of resistance on one side equal to the ratio of the other side. Look at this. Here we are having a diagram. Okay. In this diagram, E represents the voltage source. R1, R2, R3 and R4 are known resistance with precise value. Rx is an unknown resistor you want to measure. The voltage across the middle node where R2, okay, here you can observe over here R2 and R3 meet is measured to determine the value of Rx. By adjusting the value of resistors R1, R2, R3 and R4, the bridge can be balanced, which occurs when the voltage at the middle node is 0. Okay. At this point, the ratio of the unknown resistance can be used to calculate the unknown resistance. Here we are going with a formula. When the bridge is balanced, it is given by I1 R1 equals I2 R2. For the galvanometer current to be 0, okay, the following conditions should be satisfied. Here we are having a two currents, I1 as well as I2, whereas I1 it is going through in the C node, it is flowing through the I3. So I1 equals I3 equals, that is we know the Ohm's law, V by R. I is equal to V by R. So we are going with the voltage source as E divided by the resistance which is bifurcating, that is R1 plus R2. Take this as equation 1, take this as equation 2, whereas I2 as well as I4 which is equal to E divided by R2 plus R2. Take this as equation 3. Okay. Now we need to substitute these two equations in this equation, where I1 I will substitute E divided by R1 plus R3, whereas I2 I will substitute as E divided by R2 plus R4. So after substitution, I need to know the unknown resistance, that is R4 is equal to, okay, R2 divided by R2 into R3 divided by R1. Okay, this is your theory part. When it comes in a Scilab, we are having a program code. Okay, here we have written the program. Okay, here we are having a program. I will explain one by one how it is. First code, it is called as CLC, that is nothing but this command clear the command window to provide the clean output space. Okay, the first, whenever we start the program, we need to have these two initially. Listen students, first when we start the program in a Scilab, we need to have these two commands at the earliest, that is the first point of this program. When we execute this program, this need to be there. Okay. Next, clear all. This command which helps to clear all the variables in the workspace, ensuring that there is no conflicting variables. Okay. If you are having already pre-registered variables, it will clear by using this clear all. Next, we are assigning the values, that is R1 is equal to 10, that is in the form of kilo ohms. Okay, assigning a value of 10 kilo ohm to the variable R1 representing one resistor in the Wheatstone bridge. Same way here we are representing R2, that is 15 kilo ohm, R3 it is 40 kilo ohms, okay, and we are having a formula Rx, whatever unknown resistance, it should be equal to R2 into R3 divided by R1. That is nothing but unknown resistance, it is represented by Rx. Otherwise if you are having a here this is your unknown resistance, it is represented by Rx, or I can conclude this one as a R4. So when we display, okay, here DISP, it is Rx, we need to display the resistance whatever we are having in kilo ohms, okay, here that is used to display the text, the unknown resistance Rx, okay, what is it is equal to the window command. In window command it will display, and later on the value whatever we are getting, that is R4 is equal to whatever we are having over here, R4 is equal to R2 into R3 divided by R1, will get the value as 60 volts, 60 kilo ohms, okay. In the next slide we are showing the output how we are getting. Here we are having, just see here, we have assigned the value as R1, that is 10 kilo ohm, R2 15 kilo ohm as I explained earlier, R3 we have assigned with value of 40 kilo ohm. So at last we need to know the unknown resistance, that is Rx is equal to 60 kilo ohms, what we are getting over here. This is the program we are running through the Scilab. After that we are getting the value over here, that is the displayed value we are getting, it is in the kilo ohms, okay. By this we are ending up with a Wheatstone bridge. Now we are coming over with a Kelvin's double bridge, okay. The both bridges, Wheatstone bridge as well as Kelvin's double bridge, both are used to measure the resistance, but here Kelvin's bridge, Wheatstone bridge is used to measure the ohms, okay, very low resistance ohms, whereas Kelvin's double bridge, it is used to measure the very low resistance, okay, it is in the form of milliohms, okay. Here coming to the theory part, Kelvin's double bridge is a modified of the Wheatstone bridge that allows to measure the very low resistance, okay. It includes additional resistance and second bridge to compensate. Here we are having a second bridge, additional resistance, that is Rk, okay. Here that resistance has a lid which can affect the measurement as such of low values. In this diagram we can have E as a source, voltage source, R1, R2, R3 and R4 are known resistors with precise values. We need to assign the values for that one, okay. Rx here are Rk, we will represent it as a Rx or Rk, okay, is an unknown resistor, we want to measure it, okay. Students need to measure that resistance, okay. Here first we will come with the working principle. The working principle of Kelvin's double bridge involves creating two separate circuits, one pass the measuring current through the unknown resistance and other to measure the voltage across it, okay. Here we are going to achieve by adding an external resistance, that is Rk or Rx, okay. And let's have, we are having Ra to Rb as 1000 ohms, R1 5 ohms, R1 it is nothing but it is half of the R2, so 0.5 of R2 we need to have. This is the design part, and when we comes with the program code, as already said, here we are having a first two rows, that is CLC, it will clear the command, second one clear all. This is used to clear all the variables in the workspace, okay. It will free up the memory or reset the variables, so pre-assigned variables if it is there, it will clear all the things. So next we are going to assign the values. Here RA underscore B, it is given as 1000, okay, assigning the value of 1000 to the value of RAB. R1 5 ohms, here R2 it is nothing but I said R2 will be half of R1, so I am dividing it by, that is 1 by 2, so whatever it is there, if the R1 is 5 ohms, so R2 will be 2.5 ohms, okay. Next Rx, we are having a formula over here that calculates Rx as R2 divided by 1000, R2 divided by 1000. This means that setting up a Wheatstone bridge where Rx is unknown resistance being calculated. Next we need to print the value whatever we are getting, that Rx value, okay, that is assigned over here. The results whatever I am getting, the value will be 0.01 ohms. You can observe over here, this is a bridge. Kelvin's double bridge is used to measure the very low resistance. Wheatstone bridge is used to measure the low resistance, whereas Kelvin's double bridge is used to measure the very low resistance. It is in the form of milliohms. Okay. By this, here we are showing with the program. Same thing, I have assigned with the value of R underscore B, that is 1000, R1 5, R2 that is nothing but 1 by 2 of R1. So Rx, we are having a formula over here, unknown resistance I need to find out. So next we need to print the value, that is what I am getting the value over here, that is 0.0 ohms. Here the variables you can observe over here, I have assigned with value of 5. So when we double it, R2 we are getting with a 10 ohms cross multiplying. So R3 we are having 40, Rx 0.0 ohm, that is what value we need to get it. Here we are having those values. Okay, with this we are winding up Wheatstone bridge as well as Kelvin's double bridge. Here is the outcome. The Kelvin's double bridge is a modified version of Wheatstone bridge and provides a high accuracy compared to Wheatstone bridge. Okay, here both are used to measure the first thing we need to know, both are used to measure the resistance, and here Wheatstone bridge is used to measure the low resistance, whereas Kelvin's double bridge is used to measure the very low resistance. It is in the form of milliohms. Okay, with this we are going to sign up with the first experiment. Okay, here you can check with that, the design and analysis of measurement of resistance using Wheatstone and Kelvin's double bridge.